I'm Anil Kumar, and in this video we'll try to understand why do we get extraneous solutions to rational equations. Well, consider the example in the book. They have also provided you with the reason, but we'll explore it further. The question is 5 divided by 2x minus 2 equals 2, 15 divided by x squared minus 1. When we solve, we find that x equals to 1 is extraneous solution, since denominator becomes 0 when you substitute x equals to 1 in the given rational equation. Now the question is, could we see it right in the beginning? What is the criteria? And how can we figure out, without even solving, that it is expected to get this kind of extraneous solution? This is what we are going to explore. Thank you. I'm Anil Kumar, and now we will explore why sometimes we get extraneous roots when solving rational equations. Now the question here is, explain why the following equation should have an extraneous solution at x equals to 1. The equation is 5 over 2x minus 2 equals to 15 over x squared minus 1. So we are again working with the same example in the book, and this time we are working in a reverse order. We know that the solution is including extraneous root, which is not the real solution. But after all, can we guess it right in the beginning? That is the whole idea. So what I will do here is, we'll factor the denominators and then solve this rational equation. So let me rewrite this equation after factoring the denominators. So here we get 2 is a common factor. We get x minus 1 equals to 15 over, this is difference of squares. So I can write it as x plus 1 times x minus 1. Now the very first step to solve this is cross multiply, correct? So when we cross multiply, what happens? We get 5 times x plus 1 times x minus 1 equals 2. 15 times 2 is 30, so let me write 30 times x minus 1. As you can see, one of the solutions is x equals to 1. Now if I substitute x equals to 1 in the denominator, it will be 0. But after all, from where did we get this factor? X minus 1 was the factor in the denominator. We cannot equate it to 0. If we do, then it results into indeterminate or something divided by 0, which is not possible. So when you introduce by multiplying with common factors like this, there is always a risk of introducing an error, correct? So I will solve it in kind of a different way. I'll bring all these terms to one side. So we have 5 x plus 1 times x minus 1 minus 30 times x minus 1 equals to 0. We can now factor x minus 1. So what do we get? We get 5 times x plus 1, right? Let me open this up. We get 5x plus 5 minus 30 equals to 0, and that gives us x minus 1 times 5x minus 25 equals to 0. So from here we get two solutions, correct? One of them is x equals to 1. Let me rewrite this. X minus 1 times 5x minus 25 equals to 0. You could factor 5 also. Let me do that. X minus 1 times x minus 5. So clearly we have two solutions, x equals to 1 and x equals to 5. Now the question is, how did we get this answer? We got it because there was x minus 1 factor, a common factor in the denominator, which we multiplied with. Do you see that? And now when we are saying we are equating it to 0, if we are equating to 0, then we cannot multiply by 0 on both the sides. That is an error. Therefore, in such questions, whenever you are working with, first thing you should do is write restrictions. What will make denominator 0? For this rational equation, x equals to plus or minus 1 will make denominator 0. And therefore, we should write restriction as x is not equal to plus and minus 1. Now, when you solve the equation, the method is absolutely correct. Then since we know that the restriction is plus minus 1, you can check your answer with the restriction. If one of your answer is the restriction, then that results into extraneous solution. I hope that makes things simpler. Well, as you can see here, if we do have a common factor in denominators, that will always result into extraneous solution, as we had in this case. X minus 1 was the common denominator, common factor in both denominators, and therefore we got this extraneous solution also. I hope that makes things slightly more simpler for you to understand. Thank you.